A 2,300-year-old iron pillar is standing in open air in New Delhi right now, and it has never rusted. Scientists threw everything at it. Modern metallurgy still can't fully explain it. And that's just where we start. Fact number 1. The Iron Pillar of Delhi has a rust-proof coating that metallurgists couldn't replicate until 2002. In the Cut complex in New Delhi stands a 7.2-meter-tall, 6-ton iron pillar forged around 402 CE, that's over 1,600 years ago. For context, most iron structures exposed to air and moisture begin rusting within decades. This pillar has been standing in the open, through monsoons, through humidity, through pollution, and it is almost entirely rust-free. For centuries, Western scientists dismissed it as a curiosity. Then in 2002, a team of researchers from the Indian Institute of Technology Kanpur published findings in the journal Current Science revealing the secret. Ancient Indian metallurgists had created a thin, crystalline layer of a compound called Mesa White, a form of iron hydrogen phosphate hydrate, on the surface. This passive protective layer actually self-reinforces over time. The kicker? Modern industry did not develop comparable phosphoric passivation techniques until the late 20th century. Ancient Indian smiths had cracked corrosion-resistant metallurgy 1,500 years before the Industrial Revolution. Let that sink in. Visual note: show an animated infographic diagram of the pillar's cross-section with the Mesa White layer highlighted in a contrasting color. Use a timeline chart comparing the pillar's creation date to modern phosphoric treatment patents. Fact number 2. Ancient India performed plastic surgery over 2,500 years before the West invented it. The Sushruta Samhita, written by the physician Sushruta around 600 BCE, that's over 2,600 years ago, contains detailed, step-by-step descriptions of rhinoplasty, reconstructive nose surgery. We're not talking vague spiritual metaphors. This text describes specific surgical instruments, suturing techniques using cotton thread, the angle of incisions, post-operative care including applying licorice and sesame oil as antiseptics, and even patient recovery protocols. Sushruta described over 300 surgical procedures and catalogued 120 surgical instruments by name and function. Western medicine traditionally credits Italian surgeon Gaspar Tagliacozzi with inventing reconstructive surgery in 1597 CE. That's 2,200 years after Sushruta. The British medical journal The Lancet acknowledged in a 1794 editorial, after witnessing Indian surgeons perform nasal reconstruction, that this technique was entirely unknown to European medicine. Today, the World Health Organization and the American College of Surgeons both formally recognize Sushruta as the father of surgery. Modern peer-reviewed studies published in the Indian Journal of Plastic Surgery have confirmed that Sushruta's described flap techniques are anatomically sound and clinically viable by 21st century standards. Visual note: display illustrated diagrams from an academic reconstruction of the Sushruta Samhita techniques alongside a color-coded timeline chart comparing Indian surgical history to Western surgical milestones. Fact number 3. Ancient Indians calculated the speed of light 1,400 years before Newton was born. In the 14th century CE, the scholar Sayana wrote a commentary on the Rigveda, one of Hinduism's oldest scriptures, in which he described the sun's rays traveling 2,202 yojanas in half a nimisa. When researchers converted those ancient Sanskrit units, yojanas to kilometers, nimisa to seconds, the result came out to approximately 300,000 kilometers per second. The actual, laser-measured speed of light accepted by modern physics is 299,792 kilometers per second. That is an accuracy margin of less than 0.07%. Now, historians debate whether Sayana was interpreting pre-existing Vedic knowledge or making an original calculation. But the number is undeniable. Ole Romer, the Danish astronomer credited by Western science as the first to measure the speed of light, did so in 1676 CE, more than 300 years after Sayana wrote that commentary. Drive S. Da, an astrophysicist who published an analysis of this in the Indian Journal of History of Science, called the numerical precision remarkable and difficult to dismiss as coincidental. Visual note: use an animated infographic showing the unit conversion chain from yojanas per nimisa to km/s, ending with a side-by-side comparison bar chart against Ole Romer's 1676 figure and the modern accepted value. Fact number 4. The Indus Valley had flush toilets and sewage systems 4,500 years before Rome. When archaeologists excavated Mohenjo-Daro and Harappa, major cities of the Indus Valley civilization dating to approximately 2,500 BCE, they found something that stopped them cold. Nearly every single house had its own private flush toilet connected to a covered drainage network that ran beneath the streets of the entire city. Not a communal pit. Not an open ditch. A city-wide, brick-lined, covered sewage system with inspection manholes, overflow channels, and settling basins. The cities housed an estimated 40,000 to 80,000 people. Rome, often celebrated as the pinnacle of ancient engineering, built its famous Cloaca Maxima sewer around 600 BCE. That's nearly 2,000 years after the Indus Valley was already operating a more sophisticated per-household sewage system. A 2016 study published in the journal Environmental Science and Technology analyzed the engineering geometry of Indus drainage channels and concluded they were designed with deliberate gradient calculations to maximize flow efficiency, demonstrating intentional hydraulic engineering, not accidental construction. Visual note: show an overhead archaeological site map infographic of Mohenjo-Daro's drainage grid in blue overlay, compared to a scale timeline chart showing Indus sanitation versus Roman, Greek, and medieval European sanitation developments. Fact number 5. Ancient India discovered gravitational attraction 1,200 years before Newton's apple. In 628 CE, nearly a millennium before Isaac Newton formalized the law of universal gravitation in 1687, Indian mathematician and astronomer Brahmagupta wrote in his masterwork Brahmasputa Siddhanta, "Bodies fall towards the earth as it is in the nature of the earth to attract bodies, just as it is in the nature of water to flow." That is a clear, unambiguous statement of gravitational attraction as an inherent property of the earth, not divine will, not mystical force, but a physical property of matter. Brahmagupta also calculated the Earth's circumference as 36,000 kilometers. The actual value is 40,075 kilometers. He was off by approximately 11%, using only mathematical reasoning and shadow observations over 1,300 years ago. A 2019 analysis by historians of science at Cambridge University Press, published in the journal History of Science, formally acknowledged Brahmagupta's gravitational statement as the earliest clearly articulated expression of terrestrial gravitational attraction in recorded scientific literature. Visual note: display a split-screen infographic, Brahmagupta's original Sanskrit passage on the left with English translation, and a timeline bar on the right marking 628 CE versus Newton's 1687 Principia Mathematica, with the 1,059-year gap highlighted in a bold color. Fact number 6. Vedic texts described atomic theory 2,600 years before Dalton. In the 6th century BCE, around 600 BCE, the Indian philosopher Acharya Kanad, founder of the Vaisheshika school of philosophy, proposed that all physical matter is composed of indestructible, indivisible particles he called Parmanu. He described these particles as too small to be perceived by the senses, eternal, in constant motion, and capable of combining in specific ratios to form compound substances, Dvyanuka, 2 atoms, and Trianuka, 3 atoms. Compare that to John Dalton's atomic theory, published in 1808 CE. Dalton described atoms as indivisible, indestructible, specific to each element, and combining in fixed ratios to form compounds. The conceptual overlap is extraordinary. Dalton gets the credit in Western textbooks because his model was mathematically formalized and experimentally tested, fair enough. But the philosophical and structural framework Kanad described 2,400 years earlier contains every core conceptual element of modern atomic theory. Dr. A. L. Basham, the Oxford historian and author of The Wonder That Was India, wrote that Kanad's atomic hypothesis represents one of the most remarkable intellectual achievements of the ancient world. Visual note: create a side-by-side comparison infographic with 2 columns, Kanad's Parmanu theory, 600 BCE, and Dalton's atomic theory, 1808 CE, with matching bullet points in contrasting color blocks showing conceptual parallels. Fact number 7. Ancient Indian astronomers knew Earth was a sphere and calculated its rotation, in 499 CE. In 499 CE, the mathematician and astronomer Aryabhata published his landmark work, the Aryabhatiya, at the age of just 23. In it, he declared, against the prevailing global consensus, that the Earth is spherical, that it rotates on its own axis once every 23 hours, 56 minutes, and 4.1 seconds, and that this rotation is what causes the apparent movement of stars across the sky. The modern accepted value for Earth's sidereal rotation period, measured by atomic clocks, is 23 hours, 56 minutes, and 4.091 seconds. Aryabhata's figure differs from modern measurement by less than 1 second. 1 second. Over 1,500 years ago. He also calculated pi to 3.1416, accurate to 4 decimal places, and determined the length of the solar year as 365 days, 6 hours, 12 minutes, and 30 seconds, compared to the modern value of 365 days, 6 hours, 9 minutes, and 9.54 seconds. His solar year error was less than 4 minutes across an entire year. A 2018 paper in the Journal for the History of Astronomy called Aryabhata's rotational calculation a precision that challenges modern assumptions about the limitations of pre-telescopic astronomy. Visual note: display an animated circular diagram of Earth's sidereal rotation with Aryabhata's value versus the modern atomic clock value shown as two near-identical arcs. Include a data table infographic comparing all his calculations to modern confirmed figures. Fact number 8. Ancient India invented binary numbers, centuries before Leibniz and 2,600 years before the computer age. This one directly underpins every single piece of technology you are using right now to watch this video. The entire digital world, every computer, every smartphone, every AI system, runs on binary code, sequences of zeros and ones. Western history credits Gottfried Wilhelm Leibniz with inventing the binary number system in 1679 CE. But in the 3rd century BCE, that's around 200 BCE, Indian scholar Pingla, in his work the Chanda Shastra, a treatise on Sanskrit poetry meter, developed a complete binary system using short and long syllables, what he called Lagu and Guru, to encode all possible metrical patterns. He described a method for converting binary sequences to decimal numbers and back, the exact same process used in modern computing. He also independently discovered Pascal's triangle, 1,800 years before Blaise Pascal, and the Fibonacci sequence, 1,300 years before Fibonacci. A landmark 2003 paper by mathematician and historian Kim Plofker of Brown University, published by Princeton University Press, formally documented Pingla's binary system and stated it represents a fully operational binary notation predating all known Western equivalents. The device you are watching this on? It's running on a system a Sanskrit poet sketched out over 2,200 years ago. Visual note: show an animated infographic converting a Sanskrit metrical pattern from the Chanda Shastra into binary notation using a color-coded grid, then show the same grid transforming into a modern 8-bit binary byte. End with a timeline bar showing Pingla at 200 BCE, Leibniz at 1679 CE, and the first digital computer at 1945 CE. And there it is. 8 facts about ancient India that modern science has spent decades, sometimes centuries, scrambling to catch up to. From a rust-proof pillar that stumped metallurgists for 1,600 years, to surgical techniques that predate Western medicine by 2,500 years, to the binary code powering your phone right now, ancient India wasn't primitive. It was running laps around civilizations that get all the credit in your history textbooks. The question isn't why ancient India was so advanced. The question is, why did it take us this long to listen? If this video made you look at history differently, smash that like button. It genuinely helps this channel reach people who deserve to know this stuff. Drop in the comments, which fact hit hardest? I'm reading every single one. Subscribe to Moonlit Minds for daily mind-blowing facts that will change how you see the world.